Hello everyone, I am Engineer Ranadip Chakraborty. You are watching Bastukar, the Bong Engineer channel. Today I will be discussing regarding how to calculate the load on column. So today you will be learning the load calculation procedure for the column designing. I will be showing you what is the influence area and how to calculate the load on the column which is acting on it, the types of the load we have to consider, and a step-by-step calculation with an example. So let us continue without further any of blabbering. Okay, let us consider a frame structure like this, okay, which is actually of 9 columns, composed of 9 columns, where center to center distances are 6 meter from left to right. I am talking 6 meter and 4 meter from left to right, and from top to bottom it is 3.5 meter and 4 meter. Okay. So, how to calculate the loads for designing a column? See, there are different types of loads like gravity load and lateral thrust, mainly these two types. In the lateral thrust, there will be earthquake loads and wind loads. In the gravity loads, that is the loads which are acting along the direction of the gravity, that is vertically downward. There will be mainly of two types of loading. One is dead load and the other is live load. Dead load means the load which is fixed in nature, which cannot be moved from one place to another place. Loads coming due to those kind of objects or elements in a constructional member as a whole is called as the dead load. Like what? Like the load of the slab, load of the column itself, and so on. Live loads is the load which is coming due to the elements or objects which can be moved from one place to another place, right? Like those coming from the furnitures, and due to movement of the humans, these kind of loads are live loads. There are several other types of loads like impact loading, rolling loads, but those are not important from this perspective. Suppose you are having a plan with you like this one or anything which is much more complex. You can calculate the load coming into it in two simple steps. First of all, you need to know from which area a particular column which you are about to design is getting the loads into it. That particular area from where a particular structural member is getting affected, that is the area which is influencing a particular member is called as the influence area for that particular structural element. So, first we have to determine the influence area for the column, and then we will calculate the loads within that influence area which are present. That will be the final load on that particular member. So, this basic data I am writing. These are the basic data which are required for the calculation of the loads. Okay. Next, what we have to do, we have to find the influence area. Now, how to calculate the influence area? Let us see. So, in this particular plan, if you need to calculate the influence area, it is well understood that from left to right, the portion between the column A3 and B3 will be shared by these two columns, that is 6 meter span. Similarly, the portion of 4 meter between the B3 and C3 column will be shared between the B3 and C3. Same goes in the other direction also. The span of this 4 meter will be shared between A1 and A2, and this span of 3.5 meter will be shared between A2 and A3. So, to draw up the influence area, what we will do, we will just draw the midline between the two adjacent columns and we will get the influence area of those columns automatically. Let us see how. So, to find out the influence area, what we have to do, we have to just draw the line from the middle portion of the adjacent columns. I am just showing what to do. Just we will be drawing line from the middle portion of the adjacent columns. So, this will be in two parts, 3 meter plus 3 meter, and this will be in two parts, 2 meter plus 2 meter. Let us just cross check it. 3 meter and this is supposed to be 2 meter. Okay. Similarly, this will be also 2 meter and this one is going to be 3 meter, right. Similarly, we have to draw line from the middle of this part, that is a line between A3 and A2. Okay. So, we have divided the portion between the top row of the column and the middle row of the column in half. So, it will be 1.75 meter, that is 1750 meter from the center. Yes, it is absolutely correct. We have to do the same for the portion between the A2 and A1 part also. We will just simply draw a line. The main idea is to divide the portion between the columns which are adjacent into half, because they will share 50-50%. So, now the column A3, this column will carry the loads coming into the influence area, which is like this. I am just showing in it hatch. This area which is shown in hatched lines will give the load or will influence the column A3 only. Now, if we look at this, we can easily understand that this column which is in the center B2 will be getting the highest amount of load, right. Let us shade it. So, this whole area is the influence area of the column B2, this column. We can easily calculate this area by multiplying with the each sides with the other. We know that this side will be 3 meter plus 2 meter, because half of the 6 meter and half of the 2 meter, that is 5 meter, and this side will be half of the 3.5 meter and 4 meter, that is 2 meter plus 1.75 meter, that is 3.75 meter. So, let us just calculate the influence area first. So, it is coming as 5.00 multiplied by 3.75. (18.75 square meter). So, this 18.75 square meter area is the influence area of the column, which one? B2. Okay. This B2 column will be having the load within this influence area. So, whatever load is coming in this influence area will influence the column B2. How much load is coming? This shaded area will typically have the loads of the slab of this area. Okay. I am just working loads for a single story. Okay. If it is 2 or 3 story, we have to multiply with the number of stories. So, as simple as this. So, this column will be having the load of this much of area, whatever load is situating in this area. Now, let us see what kind of loads are in here. We will be having the load of this slab, then the finishing, floor finishing works on this slab, these beams which are running in perpendicular direction, the rib of that beam, because a part of the beam is already included in the slab itself. So, whatever remaining part, the wave, the rib of the beam which is lying below the slab, we have to calculate the weight for that thing also. Next is the column stem itself, the portion of the column between the floor level and the beam bottom level of the next higher floor. The load from that column part we have to take. Next is the wall. Whatever wall we are having within this influence area, we have to calculate the load for that wall also. We know the wall will be situated on these beams only. So, the length of the beam will give the length of the wall. This is the main dead load. Okay. And what is the live load? Live load is already standardized in IS 875. So, we can find the live load or the imposed load depending upon the type of the building. Let us consider it a residential building. So, we know that for residential building in room portions, it will be 2 kN per meter square. So, we know the area of the floor which is affecting the column, that is the influence area, and we know the load intensity of the live load. So, we can easily find out the total load acting on this column. We will just simply add the dead load and live load and we will get the total load acting on this column. So, as I have already told that I will be giving the loads for the gravity loadings, which is the dead load and live load. Let us just calculate the dead loads and live loads. Okay. Types of dead loads, what we are going to have in the structure. Okay. I will be numbering it one by one and calculating the same. Okay. First of all, due to column stem, so we know that column is made of RCC, that is reinforced cement concrete. To work out the load due to the RCC stem, we have to find out the volume of the concrete and then multiply with 25, which is the density of the RCC as per IS 456 2000, and also it is mentioned in the IS 875. So we know the volume will be cross sectional area multiplied by height. We know the cross section. Height will be the length between the floor level top and length up to the bottom of the beam web. So it will be 3 meter, that is the floor to floor height, minus total depth of the beam, that is 0.30, right, and we have to multiply it with density, that is 25 kilonewton per meter cube. So it will be coming to 0.3 into 0.3 into 2.7 into 25, 6.075 kilonewton. Second, due to beam rib or web, same thing, we have to calculate the volume and multiply with the density. We know that we have to multiply 3 dimension, that is length, breadth and depth. Length is something we have to find out. We know that this total is 5 meter, because 3 meter plus 2 meter, and this total will be 3.75 meter, right. So beam length, web length will be 5 meter. So this thing will be fully covered, this length, and plus 3.75 meter minus this portion of the width of the beam, which we have already taken from this side. Okay. So it will be 5 meter plus 3.75 meter minus 0.3, that is the width of the beam rib. So our calculation will be like this: 5 meter plus 3.75 meter minus 0.3, 8.45 meter is the length, multiplied by width, that is 300 mm or 0.3 meter, multiplied by depth, the depth of the web or rib, that is the total depth of the beam 300 mm minus the thickness of the slab, which is already included in the beam, that is 100 mm, because total depth of the beam means the beam depth including that of the thickness of the slab. The part of the slab also acts as the part of the beam, because it is cast monolithically and it will form a flange for the beam, right. So it will be 300 mm minus 100 mm, that is 0.3 minus 0.1. So this will be the volume multiplied by 25, that is the density. We will be getting the figure 8.45 multiplied by 0.3 multiplied by 0.2 into 25, 12.675 kilonewton. So we have already calculated the load due to the beam rib or web. Third comes the load due to slab. We know it will be the area of the slab within the influence area, multiply its thickness. If we multiply the area of the slab with its thickness, we will be getting the volume of the concrete, and we have to multiply it by the density to get the total load. So, it will be the influence area 18.75 square meter multiplied by thickness of the slab 100 mm slab as mentioned already. So, we get the volume multiplied by 25. $46.875 kilonewton. Fourth one, due to floor finishing, ideally the area of the floor finishing is the area of the floor which we have already considered minus the area of the wall, because the portion where we have constructed the wall there will be no floor finishing, but from the all practical purposes and for better conservative load calculation we do not deduct for those things. So, we will just simply consider the area of the influence, that is 18.75 square meter, and we will multiply with the unit weight of floor finishing. Let us take something like 0.5 kilonewton per meter square. So, we can just simply multiply it with 0.50. Okay. We will get 9.375. Next and last one, due to the brickwork, so the length of the brickwork will be same as that of the length of the beam web, because we place the brickwork only on the beam. So, whatever is the length available within the influence area for the beam rib, that will be the length of the wall also. So, it will be 8.45, thickness of the wall is 0.25, and height of the wall will be the height between the floor and the beam rib bottom, that is the same as that for the column stem height. So, it will be, as we already know, that it will be 3 meter minus 0.3, that is 2.7 meter, and we have to multiply this volume with the density that is for brickwork 19.20 kilonewton per m cube. So, it will be 8.45 multiplied by 0.25 multiplied by 2.7 multiplied by 19.2. So, 10.951 we can take. So, these are the dead loads. So, we have to make it total. .075, 675, 5 plus 375, 10.951. It will be coming to 85.951. 85.951 kilonewton, okay, per floor, right. We have already considered the loads only for a single floor. Suppose it is a two-storied building, so we have to multiply it with 2, okay, and we have to now do the workout for the live load. Live load on structure. So, at the rate of, we have already told that I am taking an interior column considering it a residential building, and the portion of the influence area which we are considering is for the say room portion. So, it will be having a load of 2 kilonewton per square meter. So, we have to just multiply the influence area 18.75 what we have got already with 2.00. So, it will be 18.75 into 2, 37.5 kilonewton, right. Now, it is also for the per floor. Okay. Therefore, total load per floor for column B2 will be dead load plus live load. So, it will be 85.951 kilonewton plus 37.50 kilonewton. Okay. So, the figure will come to 123.451 kilonewton. This will be the load per floor. Okay. We can take it as, for conservative considerations, we can take it as 124 kilonewton for easier calculations later on, and it is per floor load for that particular B2 column only. So, if the number of floor is 3, then we have to multiply it with 3, and for some columns it will depend, because some columns may be extended beyond the original roof level due to the staircase portion. So, we have to calculate for those columns separately the additional load, and also the load of coming from the staircase is different from that coming from the normal floor area, because the staircase is inclined. So, it will be having a much more area, and there will be steps, there will be waste slab of greater thickness, the live load will be also much more heavier. But in general, the calculating procedure is like this. Okay. So, I hope that you have liked this video and you have already understood how to calculate the loads on the column and what is the influence area. If you do like my video, then please do share, subscribe and leave your comments, so that I can be inspired and be motivated for further making any of these kind of videos for you. Thank you.